All right, so question number 1 here is just like question number 6 from the questions we did yesterday in class. All right, it's actually a work energy theorem question. So we have a catapult loaded with a rock, pulled backward 2.5 meters. So we have a distance there, okay, 2.5 meters, okay, using a force of 14,000 newtons. Okay, if the rock has a mass of 110 kilograms, okay, what's the speed it will leave the launcher at? Okay, so give them 1 mark if they have their givens, 1 mark if they have that work is a change in energy. Okay, in this case, we're looking at force times distance equals 1/2 mvf squared minus 1/2 mvi squared, but sitting in the launcher, how fast is it moving? It's not, okay? So that would be 0, okay? So they can have their 3rd mark for this, okay? And then we got to manipulate for VF, so we're going to have force times distance divided by 1/2 of m square rooted. Okay, so plugged in, that's going to be 14,000 times 2.5 divided by 1/2 times 110. Okay, so give them a mark if they've got that step there. Okay, so we've got 14,000 times 2.5 divided by 55 square rooted. All right, so we're looking at, it'll leave the launcher at 25 meters per second. 5th mark. Okay, questions on that? All right. So question number 2, all right, going to have this situation here. Okay, the roller coaster at the top of the hill is moving at 3.25 meters per second. The hill is of an unknown height at this point. Okay, when it's 12 meters off the ground, that's down here. Okay, the cart is moving at 31 meters per second. So if they got some givens like that written down, great. All right, we're looking for the highest point on the ride. So we have EI equals EF. It's a law of conservation of energy question because they don't say anything about friction or anything like that. So we're going to have EP initial plus EK initial, and we have both of those because there's speed and a hill at the beginning. Okay, equals EP final plus EK final, and we do have both of those because there's a height and a speed at the end. So if they get something like that, that's their 2nd mark. Expanding out further, we have MGHI plus 1/2 MVI squared equals MGHF plus 1/2 MVF squared. Okay, at this point, if you wanted to keep M and put in 350 every time there's an M, that's fine. I don't like doing that. I don't need M, so I'm taking it out, so I have less to move around. I'm trying to solve for HI. So I'm going to move 1/2 VI squared over to this side by subtracting it, and then I'm going to divide both sides by G. So I'll end up with this. The initial height will be GHF plus 1/2 VF squared minus 1/2 VI squared divided by G. Okay, so that can be their 3rd mark. Actually, you know what? That should be their 4th mark. Their 3rd mark is for properly expanding it out. Okay, they'll get a 5th mark for plugging in the numbers correctly. So HI will be 9.81 times 12 plus 1/2 times 31 minus 1/2 times 3.25 squared. Those are both squared, sorry. Okay, divided by 9.81. So 31 squared minus 0.5 times 3.25 squared divided by 9.81. All right, so the initial height of that roller coaster is 60 meters. I think we only have 2 significant figures there, right? Yep. So 1 mark for this step and 1 mark for the initial height is 60 meters. That should be 6 marks. Yep. All right, so mark out of 11, I think. Okay, mark out of 11 at the top. Let them see it. Hand them in on the table there, please.